All right, Tiffany. Let me go ahead and put my disclaimer out there that it's been a while since I've done this level of geometry. So, some of this may not be perfect, but I'll try to get it correct, of course. All right, so like I said, I'm gonna go over some of this stuff with you, and then I will leave some undone for you to do. And if you want me to check your answers for you, you can just text me a picture of your answers or whatnot, and then I can let you know if you're on the right track. All right, number one said 3 points that are not collinear. Well, basically, um, to be collinear, they need to be on the same line. So really quick before I go through this, I know that you have it in your notes, but here are a few terms that I found that you have to use a lot in this. So collinear points basically are points on the same line. Coplanar points are points on the same plane. For lines to be parallel, they must be on the same plane and never intersect. And for lines to be perpendicular, must form 90-degree angles. All right, perpendicular lines must form 90-degree angles. They may be in the same plane, they may not be in the same plane, just so long as they intersect and form a 90-degree angle. And then skew lines never intersect. All right, they never intersect. And, all right, so they never intersect, but they are not parallel. So that means they are not coplanar. Because if they don't intersect, but they're on the same plane, they would have to be parallel. Okay? Since they are not parallel and they don't intersect, that means they must be on a different plane. And you'll see that in a minute on an example. I'll show you what it means. Okay, so with that in mind, skew lines never intersect and they're not parallel, which means they're different planes. Perpendicular can be different planes, but they must form right angles. They must intersect. Parallel must be same plane and never intersect. Coplanar points are on the same plane. Collinear points are on the same line. All right, so going back to here. The first one says name 3 points that are not collinear. Well, if you look for the line, this is your line. So 3 points that are not collinear. The only point that does not lie on that green line would be point E. So you can pick any 2 points and include E with it, and they would be not collinear. So for instance, I could say AB, and as long as I put E, they're not collinear. I could put BC, as long as I put E, they're not collinear. So then you can pick another one and make sure, okay? All right, number 2 says, let C be the set of coplanar lines with a given line, S be the set of lines skewed to that line, and P be the set of lines parallel to that line, and then draw a Venn diagram. Okay, so first of all, it says that what we're going to do is we're going to let C be a set of coplanar lines with a given line. So basically I have a plane, and I'm going to call this G, my given line, and then I have lines on the plane with G all over the place. And this is going to be represented by letter C. That's my set C because they are coplanar. Then I have a set that's called S for skew, and S is skewed to all the planes, excuse me, all the lines that are in this plane. So remember, skew meant that they cannot touch and they're not in the same plane. So that means skew will never overlap with coplanar. So all my skew lines must be on a different plane. It can never overlap with the coplanar lines because if it touched them, intersected them, then it would no longer be skew. All right, and then it says a set P for parallel, and it says that I want it parallel to my given line. Well, to be parallel to the given line, they have to be on the same plane and never intersect. So all the lines that are parallel to the given line must be in the same plane and never cross. So this line right here, let me just highlight it, it'll be fine. Make it yellow. That yellow, that's not, that black line, the red line, whatever. That line to be parallel must be in the same plane and it never crosses. So actually for two lines to be parallel, they're already coplanar. So every set of parallel lines are coplanar with one another. So the set of parallel lines is inside the set of coplanar, and the skew set never crosses either. Okay, I'm not sure if that helps. Hopefully it'll help a little bit. All right, so then number 3, it says label each of the following as true or false, and if false, explain why. So letter A says any two distinct lines that do not intersect are parallel. Well, I'm going to leave this one to you. Notice it says that do not intersect are parallel. So check those definitions, and then I want you to answer that one. You can get back to me and I'll let you know if it's right or not. All right, letter B says if a plane contains one point of a line, then it must contain the entire line. Okay, so let me show you this. See this box right down here? Let's take a look at it. The top of the box is a plane. The right side of the box is a plane. The front of the box is a plane. Every side of the box can be considered a plane. So top, bottom, left, right, front, back, those are all planes. All right, so let's look back at the question. It says if a plane contains one point of a line, then it must contain the entire line. So let's say I just draw a random line. Well, let's say that that line went to the plane here. Does that contain the point? So my top of my box does contain it, doesn't it? And if we think about planes as going on forever, if that plane and the line had the same tilt, then the plane would technically contain the line, right? But now let's look at another example. Let's say that my box was sitting flat on a desk. This box was sitting flat, and directly down I have a line going through it. So it crosses through this top and this bottom here and there. Now remember my plane is going out here and here. So does that red dotted plane, which goes on forever, contain the full line? That's the question. All right, so here's a better visual. Notice how this is a plane, and this line goes through the plane, right? You see underneath here, it's like you took a pencil and you push it through the piece of paper. Top, part of the pencil's on the bottom, part of the pencil's on the top, and it goes through at this point. But does this plane contain the whole line? All right, I'm going to leave you to answer that question. But notice it says, if a plane contains one point of a line, then it must contain the entire line. So now you tell me yes or no, true or false. All right, so C says for any two distinct points, the segment A to B must be equal to the segment A to B. So if you notice the difference, and this is where I'm kind of just going off of my intuition because I don't ever remember notation like this in geometry, but my understanding of this question, it means that if I have segment AB, so let's take this, it means I have a line segment that has the endpoints A and B. And notice how the open dot's on A, that means A is not included, but we can get really close to it. And then on this segment, I have a segment that contains A and B again, but this time A is included, but B is not included. And the question says for any two distinct points, the segment which I have done in blue, is going to have to equal to the segment that I've done in red. For any two distinct points, those two segments would have to be equal. I'm assuming the points that they mean are the endpoints A and B. So honestly, if I had to take a guess, I would say yes, they have to be, even though A and B aren't included because it gets infinitely close. But if you had time, you may want to just make a note to your professor that you realize that they're the same and they get infinitely close, but you don't know if you should say yes because technically A is not in the first one and B is not in the second one. So I know that's not a direct answer, but at least you can see the comparison between them. And since they're saying if this was 3 and this was 4, then this would be 3 and this would be 4. I'd say I'd say no actually because technically this isn't going to be the whole length from 3 to 4 because it could be the length 3.1 to 4 or 3.001 or 3.00001. It's never actually 3. And then here, this isn't actually 3 to 4. It's 3 to 3.9 or 3.999 or 3.999. So I don't know. That's the question. I would say theoretically, yes. Um, so yeah, you see my dilemma. I would actually ask the professor about it. I would say yes because you're getting infinitely close to A with this segment, and yes because you're getting infinitely close to B in that segment. Okay. All right. Sorry, I didn't have a complete answer, but hopefully you at least understand the question a little bit more. All right, letter D says a ray contains no endpoints. So really quickly, a ray, remember, is composed of a endpoint and it goes through another point. This is the initial point, and this point tells you in which directions it's going. This is initial point is also called the endpoint. Now, a ray only contains one endpoint, but it does contain an endpoint. So this says a ray contains no endpoints. So I'd say that was false. All right, letter E says two skew lines can be coplanar. All right, so I went over the definitions with you on those, so I'm going to leave this one to you. All right, number 4, coplanar points A, B, C, and D are such that no three are collinear. How many distinct angles less than 180 do they determine? All right, so this was an interesting question. It really made me think, and I don't honestly know if I've got it 100% right, but I have a point A, I have a point B, I have a point C, and I have a point D. It says no three are collinear, which means no three form a straight line. If they were collinear and they formed a straight line, then I'd have an angle that was 180 degrees. Well, as it is now, if I connect any 3 points to make an angle, it's not 180 degrees. So there's one angle, oh, same color. Here's one angle, here's one angle. So you could sit down and you could try to draw all the angles. Or we could say, well, it takes 3 points to make an angle, right? And each one of the points would be a vertex. So if I took point A, for instance, and I said, well, if A is the vertex, remember the vertex is the middle, like A, B, C. If A is the middle, then I could have endpoint, I could have an angle BAC, I could have an angle CAD, or I could have an angle BAD. 3 distinct angles, right? It might be easier if we do it like this. If A is my middle, so let's let this be BAC, then let's go to this one, CAD, and then let's go to this one, DAB. Now be careful that you don't count CAB and BAC as different. Remember, that's the same angle. Same thing here. Don't count DAC and CAD as the same, or BAD and DAB is the same. So those all, so for every 3 of those points, you have 3 distinct angles that would be less than 180. So I did it for A. Same thing would apply to B. You would have 3 angles. For C, you would have 3 angles. For D, you would have 3 angles. So it's looking like you would have 12 angles. Now, this is just my best guess. Okay, this is just my best guess. All right, so then moving on to letter 5. It says the following figure is a box in which the top and bottom are rectangles with BF and DH perpendicular to plane FGH and BCD. So basically you have a box, a square box or a rectangular box, okay? Then it asks you some questions down here. It says find the intersection of BH and DCG. Well, BH, line BH would cut across from the top left to the bottom right. So there's line BH, and it says the intersection of plane DCG. So DCG is actually this right side of the box. So where do they cross each other? Do you notice they cross right here? So here's where I might want to add another note for you. When 2 planes intersect, so I'm going to put cross. Remember, that's another way to say intersect. When 2 planes intersect, they do so in a line. Okay? When 2 lines intersect or cross, they do so in a point. And when not two, and when 1 line and 1 plane cross, they do so in a point. All right, so with that in mind, so 2 planes intersect. I have this plane and I have, and this is going to be a bad drawing here, but I have this plane and it's going through. So this is technically, whoops, that was too big of an eraser. So this is technically dotted because you can only see where it goes through. So we're saying it goes through the plane here and then it's dotted. So if they will cross in a point, so actually this right here is a good example. This plane and the bottom plane intersect here in a line. Okay? When 2 lines cross, they do so in a point. And when a plane, which we just saw a second ago, is crossed by a line, they do so in a point as well. All right, so with that in mind, let's look back here again. It says find the intersection of plane BH and DCG. Well, DCG is the right side of the box. Line BH is the line that goes through here. Notice they cross at H. Okay, and then it says name 2 pairs of perpendicular planes. 2 pairs of perpendicular planes. Remember, perpendicular means forms 90-degree angles, so these 2 planes better form 90-degree angles. All right, so I'm going to show you one, and I'm going to leave it up to you to find another. So basically, this top of the box and this right side of the box intersect at right angles. Because you see here where it says perpendicular? So they intersect at right angles. So one pair would be A, B, C. Make sure you name your planes going in order. Doesn't matter what letter you start in, just do not jump across the plane. So I could call that top ABC, and I could call this HDC. So ABC and HDC intersect at 90-degree angles. So there's one. Now see if you can find 2 on your own. All right, and then it says, what's the measure of the dihedral angle DHGF? All right, I had no recollection of ever studying anything called a dihedral angle. But so I looked, and it said D, H, G, and F. So what I was assuming that they meant was this angle here. So I should have did it this angle here. Because if I connected this point, this plane, and this point, then this angle here was formed, which they told me is a 90-degree angle. But again, this is just a guess. All right, and number 6 says use the following drawing of a triangular pyramid to find the following. So let's go up here. So here's a triangular pyramid. It says the intersection of AD and BE. Well, here's AD, here's BE. Well, AD and BE, where does AD and BE intersect? I know what I would say. Remember, intersects means cross. So you decide that, and I'll let you know if it's what I was thinking. All right, the next, let me put a star. The next one says the intersection of planes ABD. So ABD is this side of the figure, and ACD is the bottom down here. And it says where do they intersect? So where they intersect, where they cross. Remember, we're talking about the intersection of planes. So you might want to look at the notes that I just gave to you on how planes intersect and tell me where those two intersect each other. All right. Then it says the intersection of BC and AC. Well, BC is here. AC is here. So notice we have two lines. So take note on where we said that two lines cross and tell me where those two cross. A pair of distinct parallel lines if possible. All right, so remember the criteria for parallel. They must be on the same plane. So you're going to take a side of the box and you're going to examine the lines that are shown for that plane. And then you're going to say, are any of those lines parallel? Meaning, do any of the lines in the plane never cross? So I'm looking at this plane, I'm looking at the lines in the plane or that form the plane, and I'm trying to find two or more that do not cross or do not intersect. So if I just look at this left side of the box that I've highlighted, the only lines that I see is this, this, and this. Well, they all intersect. These two intersect here, these two intersect here, these two intersect there. So you check the other faces, the other sides of that plane, and tell me what you think, okay? And then it says F, a plane not determined by one of the four triangular faces. So basically, that triangle has four faces, the back, the front left, the front right, and the bottom. So they want me to make a plane. Well, so that means I need 3 points. So I'm going to pick 3 points that does not make one of those planes. Okay, so notice E is just sitting there. So I'm going to use E, I'm going to use D, I'm going to use C. If I connected those, I have created, hold on a second. Yeah, I've created a plane not determined by one of those four faces, I believe. At least that's my best guess. So see if you can figure out another one. Okay? All right. Number 7 says determine the number of obtuse angles in the following. So here's my best thing to tell you to do. Start with one side. So I'm going to start with A. If I connect it to B, that's not obtuse. If I connect to C, that's not obtuse. If I connect to D, that's not obtuse. If I connect to E, that is obtuse. So there's one. If I connect to F, that's not obtuse, that's straight. So one here. All right, then I'm going to move on to B. So from B to C, because we already did A, B to C is not obtuse. B to D is not obtuse. B to E is obtuse. So there's two. All right, so let's erase. We're still on B. B to F is obtuse. So there's three. So far we've got three. And we took care of all of B. So now let's look at C. We've already did B and A. So B and D does not work. B and E is 90, so that does not work. But B and F does. All right, so we now have 4. And then let's work with D. So D and E does not work, but D and F does work. So now we have 5. And then we do E. Well, E and F's the only one because we've already took care of all of these angles, and that's not obtuse. So it looks like we have 5. Okay. All right, identify a physical model for each of the following. All right, I'm going to give you an example of what I would think, and I want you to try to come up with your own example. So parallel lines are lines that never cross. So when you drive down the highway, you have the um, white lines on the side of the road. So maybe the white lines of the highway, if the people painting them got them straight, and you might want to make that note, if they got them perfectly straight, they would be parallel. And a right angle, you might want to say something like, when I think of right angles, I think of how the walls of a building intersect the floor to form right angles. And again, you might want to make the note that's only if the people building the house did it straight and correctly. And in parallel planes, I think of the floor and the roof are parallel planes if they do it correctly again. So you might want to make notes, or you can make your own and think of what you think, okay? All right, so I erase that. Number 9, it says find the measures of each of the following angles, and then it goes to another page. So I'm going to just write in over here. Um, so it says angle BAC. So here's A right here in the middle. That's your middle. Here's B, and here's C. So they want me to find this angle. Okay, now instead of giving you that angle, I'm going to come and I'm going to draw something similar. So I'm going to give you, let's just use this nice straight line here, and let's use this line here because it doesn't much matter. And I'm going to tell you how to find that yellow one. Well, if I look, the measure of this angle here is 90, and the measure of this is 45. So to find the measure of that angle, I would say 90 minus 45, and 90 minus 45 would give me 45. So that means the measure of this angle would be 45. We just compare between the two. All right? So see if you can't get EAC on your own. Okay? Now the next one says find DAE. Well, here's D, here's A, and here's E. So it looks like this. All right, so I'm going to go in and give you one similar. So I'm going to say, let's use this line again, and then let's go and let's use this line. Okay, so I'm going to erase this. Okay, so if I look, again, this is 90, and it crosses over here at 45. And I am not in the same side anymore. Let me back up really quick and show you this again because I don't want you to get confused. It happened to work this time, but it won't always work. So if we look at this again, I did say 90 minus 45, but sometimes they go into different quadrants, so to speak. You notice from here to here is 90, but they also list from here to here is 90. So I don't want you confused. So the easiest way to do these is say, well, I'm on 45 and I'm on 90. Well, 90 is a nice 10. So I'm going to count, that's 10, 20, 30, 40, and then it moves 5 between that little spot, so that's why it's 45. Okay? Best sometimes not to subtract. So now let me redraw this. So notice how I'm between two different quadrants. I cannot just say 90 minus 45. That's not going to work. So that's where our counting method comes in. So I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So that's 135. So that's how you would do those. All right. So now you try letter B. Let's see if you can find that. And then letter C says CAF. Well, this is F down here. So C to A to F is this. It works similarly, so see if you can do that one. And then reflex angle. Reflex angle is kind of usually it's not the obtuse, but reflex angles, from my experience, are usually bigger than 180 degrees. Okay, so if I look at BAE, B to A to E, notice I have the angle in here. That's technically, it's not called the normal angle, but it's we're going to call it normal. Then I have this big angle out here that's bigger than 180 degrees. This is what they refer to as reflex. So there's two ways. I can either count all the way around this way, or I can count this way and say 360 minus whatever this is. So again, the reflex angle is the angle, the bigger portion of your angle. It's the part that's bigger than 180. So since they say BAE, I'm used to finding this part of the angle, but they don't want this part, okay? They want the reflex, they want this part. So see if you can figure it out and tell me what that is, okay? All right, so now continuing on, let's go through all my notes here. That's what we just did up there. And I gave you different examples of all these for you to try. All right, perform the following operations. Leave your answers as simple as possible. All right, so they're giving us stuff in degrees and seconds and minutes. So I have 21 degrees, 35 minutes, and 31 seconds plus da 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 da. Well, before we go into that, I want to tell you that it's kind of, in my opinion, easier if you think about this in terms of time. All right, in terms of time. What I mean is, and I don't want you to accidentally put hours, but you can kind of equate degrees to hours. Now we know that on a standard clock, a full hour is 60 minutes, right? And then we know that in terms of minutes, a full minute is 60 seconds. So 1 minute, 60 seconds, 1 hour, 60 minutes, right? All right, with that in mind, let's just talk about something really quick. If I gave you a clock, just a standard clock, it doesn't really matter. We know 12, 3, 6, and 9, right? And I asked you, what fraction of an hour is 30 minutes? Hopefully you say, well, there's 60 minutes in an hour, so 30 minutes is going to be half, right? Half of an hour. If I asked you, what fraction of an hour is 15 minutes? Hopefully you say, well, 15 out of 60 gives me a quarter, which is 25%, right? We don't care about percents though. Then if I asked you what fraction is 45, you would put 45 over 60, and then you would say, well, that's 3/4 of an hour. Well, when you talk about, the reason I say this, when you talk about minutes, you're actually talking about what portion is over 60. So here, this is actually saying I'm using 35 out of 60 possible. And here, this is saying I'm using 31 out of not 60, but 60 times 60, which is 3,600. Now, why did I do 60 times 60? Well, there's 60 minutes in an hour, and for every one of those minutes, there are 60 seconds. So it's actually 60 times 60, which is 3,600. Okay? All right, with that in mind, I actually want to go ahead, let's skip over this part for 1 minute, and let's look at letter B. It says express the following measures in degrees, minutes, and seconds without decimals. All right, so actually, you know what? We don't have to do that. We can just start here. Okay, so now I'm not saying all that really is necessary to do A and B, but now you have at least an understanding of what degrees, minutes, and seconds are kind of like, in case you have to build on them later. Anyhow, let's look at something similar to this. So similar to this would be, let me find where I made up my similar one for you, somewhere on my paper. All right, let's say you had 20 degrees, 34 minutes, and 30 seconds. Well, just like with time, when something goes over 60 seconds, we start calling it minutes. And when something goes over 60 minutes, we call it hours. So like if I say that you have 3 hours to finish the SAT, I'm not going to tell you that you have 180 minutes, I'm going to leave it in hours. I wanted the simplified version. So anyhow, they want us to add 2 sets. So then they want me to add this to something. So let's say they asked us to do this. So I just go down the line and I straight add. Well, 30 plus 33 is 63. And then 34 plus 50 is 84. And then 20 plus 48 is 68. All right, we got something down. The problem is, remember, like I just told you, once seconds hit 60, those 60 seconds turn into a minute. Once minutes hit 60, those 60 minutes turn into an hour. So once you add them, you start at the very far end and you check. Are the seconds that you have listed bigger than 60? Yes. So you need to come to the side. And what you're going to do is you're reducing your answer kind of in a way. I need to take this 60 seconds and move it as 1 minute. So I subtract 60 from 63, and that leaves me with 3 seconds. So I actually have 3 seconds here, and I'm going to move this minute over here. So I'm actually going to add that 60 seconds that I just took from the 63 to the minutes column. All right, so now I didn't do anything with the degrees. I now have 85 minutes, and remember this is gone. I have 3 seconds. So now my seconds look good. Nothing over 60. But what about the minutes? I have over 60, don't I? So I come to the side and I say, well, I need to take out any extra. So I'm going to take this extra minute out as 1 degree, that equivalent to like 1 hour. So I have 25 minutes. This goes away. And I bring that extra degree over here. Well, I didn't do anything with that, so I bring it down. I now only have 25 minutes, and I add, and that gives me 69 degrees. So basically what I did, anything over 60, you need to move it up to the next unit. All right, so here's another example. Let's say that I had, I don't know, 36 degrees, 28 minutes, 72 seconds, and then I have 10 degrees, and I have uh, 43 minutes and 10 seconds. And they asked me to add them. So I just go to town adding. I say 72 plus 10 is 82. 28 plus 43 is what? 8, 9, 10, 11, 71. And then I say, well, this is 46. So all I did was add. And then I look and I say, oh, wait a minute, there's a problem. 82 is bigger than 60. So I come to the side and I say 82 minus 60 gives me 22. So I'm going to rewrite this as 22 degrees, and I'm going to bring that extra minute over here, which gives me 72 minutes, and I bring down to 46 degrees. And I say, all right, my seconds are taken care of, but I got a problem. 72 is bigger than 60. So 72 minus 60 gives me 12. All right, that looks better. So I bring down to 22. I've just subtracted 60 from the 72, so that gives me, oops, I didn't mean to put double marks here or here, because those are minutes, not seconds. There we go, that's better. Which gives me 12 minutes. And I move that extra 1 over here, so I have 47 degrees. So that's how you add and then simplify. So hopefully that'll help you do A1. So now let's look at an example for A2. Same type of concepts, but you have to borrow just back like you had to in elementary school. So 80 degrees, 27 minutes, 19 seconds, 38 seconds, 34, and then 10. Okay, so I go to subtract. All right, remember just how when you subtract 12 and then you have, let's say 4, and then you have something like that. I can't subtract 8 from 2, so I borrow, right, to subtract. Same rules applies here. Let me write this. That's getting on my nerves. So I want to subtract 38 seconds from 19 seconds, but I can't because it's not big enough. So I have to borrow. But you have to be careful. When I borrow a minute, I know this is turning into 26 minutes, but I'm not just borrowing one. I don't just change this into a 20 because 1 minute is how many seconds? 60. So I'm actually borrowing 60 seconds, right? 1 minute is 60 seconds. So one is going away from here, but it's coming in here as 60 seconds because this is a minute, this is seconds. Okay. So instead of 19, what I actually have now is 79 subtract 38. So I'm going to erase this. So this turns into 79 minutes. And then I can subtract. So this is a 1 and this is a 4 seconds. So now I get back to this column. I've borrowed, so that 27's gone and I'm left with 26. So I'm going to rewrite it. And I look and I say, well, guess what? I can't take 34 from 26. So I need to borrow. So this turns into 79 degrees. But remember, when I bring it over to this column, it doesn't come over as a 1. It comes over as 60 minutes. So this is no longer 26. It's 60 plus 26, which is 86. So this is actually 86 minutes. And this turns into 79. So now I can subtract, and this is 2, and this is 5, and this is 69. Okay? And just one more really quick. Let's see if I can make up something. Let's just say 10 and 4 and 20 and 40 and 38 and 50. Okay? They want me to subtract. So I see here I can't take 50 from 38, so I borrow. But remember, I don't bring that in as just a 1, I bring it in as a 60. So 60 plus 38, right? 60 plus 38 is 98. So that's what I'm working with here. So then 98 minus 50 is 48. Then I come to this column and I say, well, I cannot take 40 from 19, so I need to borrow. But when I bring it over, I don't bring it over as 1, I bring it over as 60. So this becomes 79. So now 79 minus 40 is 39. And then 9 minus 4 is 5. So 5 degrees, 39 minutes, 48 seconds. So now you should be able to try 1 and 2. All right, letter B says express the following measurements in degrees, minutes, and seconds without decimals. So when I'm looking at these problems here, it's actually not too bad. So let's say that I had, let me find my note. Let's say that I had 12.5 degrees. And they don't want it in decimals, they want it in minutes and seconds. Well, the good news is it's easy to break these up. What you do is you take the whole number, and that's your degrees. Then you take your decimal, so 0.5, and you multiply that by 60. Well, 0.5 times 60 gives me 30. So that means it's a whole number, right? So that means that I have 30 minutes. Okay? So looking at another one. So this is actually the answer, which makes sense. 12.5 degrees, well, half of 60 is 30, right? Okay, so let's say that I had 10.3. Oh, no, that's the one they gave you. Don't want to do that one. Let's say that I have 11.8. So the 11 is the whole, so that's my degrees, and then I need to figure out what portion is this. So I say 0.8 times 60, and it is always times 60 because you're breaking it up into fractions. So 0.8, I'm doing this on the calculator because I just made it up, times 60 equals 48. Notice this is a nice whole number, so that means you're done. 48 minutes. So now see if you can do that first problem. All right, but if you look at the second problem in that section, it says 15.14. So there's two decimals. Well, if I go and make up something close to that, let's say 28.24 degrees. Well, this whole part becomes the degree, and then I multiply 0.24 times 60. Well, when I multiply 0.24 times 60, it gives me 14.4. Well, wait a minute, it's another decimal. Well, you take the whole part, that's your minute, you take the decimal that's left, and you multiply it by 60. And zero point 0.4 times 60 gives you 24. A nice whole number, so you have 24 seconds. Okay, and then 37.12. 37 is the degrees. So I take the 0.12 and I multiply it by 60. So 0.12 times 60 is equal to 7.2. Well, it's a decimal, so I take just the whole number part, and that's my minutes. So what I'm doing is I'm breaking them up. So now I take this 0.2 and I multiply it by 60, and 0.2 times 60 gives me 12. So that means my seconds is 12. So that should help you be able to do part B. All right, 11 says consider a correctly functioning clock that starts ticking at noon and find the time between 12 noon and 1 p.m. when the angle measured between the hands is 180. All right, so just insert a clock here. They want to know, so here's 12 o'clock. Ignore the red hand, we don't care. And then it goes all the way around, and as you can see, it's not a working clock. And then it's at 1. They want to know at what time between this 12 and 1 do the hands form a 180-degree angle? Well, we know 180-degree angles would be that, right? Straight line, 180. Well, that's 6 o'clock. They want between 12 and 1. Well, the only 180-degree angle when the big hand's on 12 is when the little hand's on 6. Just ignore that red, okay? But what if this hand moves over just a little bit to 1? Well, the only place at 1 is when it's little hands at 7. But that's not 1 o'clock, is it? So actually, we should do it this way. Sorry. Here we go. But that's not between 1 and 12 anymore, is it? All right, so 12 o'clock. Let's move this one. It's going, it's going, it's going, it's going, it's going all the way around. But what's not happening that usually happens when the clock's moving from 12 o'clock to 1 o'clock? By this time, that little hand here should be at 1, shouldn't it? So let's do it. Let me see if I can do this at the same time. So let's start at 12. I have to. It's gonna let me. It's not gonna let me move both of them at the same time, I don't think. All right, anyhow. So we start at 12, and this one starts moving, 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 moving. And as it gets about here, this little hand's moved over a little bit, inching closer. No, to there. And then ignore the red. It's going, 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 going. And it's going, 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 going. And it's going. And then we get here. Because when I first thought about the problem, and it says at what time between 12 and 1 is 180 degrees. Well, I know that at any time that a clock has hands that are 180 degrees, it's cutting the clock in half. So I think, well, maybe 12:30. So I jump first to 12:30. But when I'm at 12:30, if you think about how the clock works actually, this little hand's not at 12 anymore. It's moved over a little bit. So that means it's a little bit past 12:30. All right, so how far past? Well, if you pay attention, and I hope this is making sense, if you pay attention to the time between 12 and 1, if you're exactly halfway between 12 and 1, you're at somewhere around 12:0, it's actually 12:025, which isn't a time, so we're going to round up to about 12:03. Well, if this is at 12:03, then the big hand better be about 3 minutes past. So it better be at somewhere between the 6 and the 7. Okay, so think about that, see if it makes sense. So if it's set like that, then that time is actually what, about 12:33? I would say about 12:33 when the hands are actually 180. Okay. All right. Number 12 says, in each of the following figures, relationships among marked angles are given. Find the measures of the marked angles. All right, so they give me a formula down under letter A, and so I have to figure it out. So I know that just looking at the picture, this angle plus this angle plus this angle go all together to form this straight line. So if I started and went all the way across, I've got 180 degrees because I have a straight line. Okay, can you see that? All right, so what else do I know? So since I know that all three of those together have to form a straight line, I know that angle y plus that 120 degrees plus x, if you add them, has to equal 180 degrees because they form a straight line. All right, so that doesn't help me very much because I have an equation with two variables. So they had to give me something else. Well, if you notice down here, it says the measure of DOC. Well, what is DOC? They're representing DOC by y. And they say the measure of DOC is equal to 3/4 the measure of angle BOA. Well, what is BOA? Okay, BOA is x. So essentially what I have are two equations. One that I set up just by looking at the drawing, and the other they actually gave to me. And I just rewrote to get them in the same form. So I know that this is what y equals, right? So that means that I can then take y in this equation and plug in this because y equals 3/4 x. That's what they told me. So since I know y equals 3/4 x, I can plug it in here. So I'm going to rewrite my equation. Instead of y, I'm going to put 3/4 x plus 120, because notice I'm just going down the line, plus 120 plus x equals 180. And now I'm just going to solve the equation. So 3/4 x plus x gives me x, excuse me, gives me 1 3/4 x, right? 1 3/4 x when I add them together. Remember to change this into a mixed number. You say 4 times 1 is 4, 4 plus 3 is 7. So this is the same thing as 7/4x. So that's what I got when I put these two together. I bring down that plus 120 and it equals 180. All right, so then I'm going to subtract 120 from both sides. 7/4 x equals 160. Oh, excuse me, just 60. And then remember, when you need to move the fraction to the other side, if it's being multiplied, you multiply by the reciprocal on both sides. So x is actually going to equal 60 times 4/7, which is 240/7, because remember, it's like this is over 1. And you have 240/7, which is not a nice whole number. I do not suggest using the decimals here, but you can. The decimal approximate would be about 34.29 for x. And now that you know that's x, you come back up here and plug in. So y equals 3/4 x was that equation that they gave to us. And now I know that x, this x, we found it right here, is 240 over 7. So now I'm going to leave that part for you to solve. Okay? All right, so now looking at B, it says the measure, I look at these angles and I know that that angle plus this angle go together to form this angle, and they tell me that that big angle is 90 degrees. So I know that this piece, which is y, plus this piece, which is x, better equal 90 degrees because that's what that little box meant, 90 degrees. So that's not enough because I have two variables. But they do tell me that AOB, which is this angle, y, is, remember, is means equals 30 less than, remember 30 less than means you're going to subtract 30, then 2 times BOC. So BOC is this angle, which is y, so 2 times y. So y, the measure of AOB, y is 30 less than 2 times BOC, and BOC is y. So what I have then are two separate equations representing the same diagram, and so you're going to solve it just like I just solved A. Okay, so I'm going to leave that for you to do from here. Okay, and now that you know about the setup, see if you can get B on your own. Okay. All right, number 13, it says how many planes are determined by three non-collinear points? Well, now these are just to the best off the top of my head. So I looked to try to figure this out. Um, let's see, let's just say I have 4 points that are already coplanar. This is, again, just my best guess. They want to know how many different planes could I draw through them. Well, I could draw a plane through ABC, so that would be these three. I could draw a plane through ACD, which takes care of those three, or I could draw a plane through ABD. So notice I've used all the combinations with A. So A has been with BC, A has been with BD, and A has been with BD. Okay? So now I've exhausted all the options with A. A cannot be used again with those three because it would result in one of these repeating. So again, before I mark it out really quick, let's erase this. So I could draw a plane through ABC. I could draw a plane from A, skip B, and go to CD. And then I could draw a plane AB, skip C, go D. So those are three different planes. So that means that I've used A with all of the other letters. So it's gone. So now I'm left with B, C, D. Well, the only combination of three letters is B, C, D. Doesn't matter how I switch those around or which one I start with, those are the only three left. So it looks to me like there are four. But again, just my guess from what I've looked online and tried to figure out. Somebody else said it too. Not that it makes it true, but anyhow. All right, and then so if there were four and you had four planes, my guess is that for n you would have n planes, but that's a guess. All right, 14 says, in each of the following pairs, determine whether the symbols name the same geometric figure. All right, well, ray AB means it starts at A and goes through B. Ray BA, notice the arrows over the A, means it starts at B and goes through A. So if I have this, let's just say I have a line here. Ray AB starts here and goes this way. Ray BA starts here and goes this way. So the question is, are they the same geometric figure? So is the red ray and the green ray that I drew, are those two the same geometric figures? I'll let you answer that. All right, and then the next one says, is AB and BA the same? So let's put a mark by this one. Well, if I drew AB, that means it starts at A and it stops at B. It's a segment. And then I start at B and I go to A. Are the red and the blue the same? That's the question. I'll let you answer it. Okay, and then C, it says is line AB. So I have a line. So that means some point it's going infinitely this way. It goes through A. It's going infinitely that way. Is that the same as starting infinitely going this way and infinitely that way? So that's the question. I'll let you answer that. Okay. All right, skipping 15 and 16. 17 says in the figure, um, and there's actually some writing in there. It says in the figure below 0 or O is the center of the circle. The measure of ACB is 90, which they gave to you. Find the following measures. Well, I see there's some writing in there. I do want to make sure you understand why they're there. Well, if I just look at this triangle here for a minute, if you recall, triangles always add up to be 180 degrees. Okay, so just keep the interior angles always add to be 180. So keep that in mind. And now let's take a second here. They told us that this was 90 and they even put the box there. Well, if it's 90 and this is 55, then 90 minus 55 gives me, oh, 35. No, I don't even put 40 there. Gives me 35, which is why someone has nicely wrote in 35 degrees for you. Okay, and then on another note, this is a straight line, isn't it? Remember, straight lines always add to be 180, so this big angle has to be 180. Well, if this piece of the big angle is 70, then 180 minus 70 is 110, which is why this angle right here is 110. Okay, so that's why those are there. So with that in mind, we can go, I'm going to rewrite that, rewrite this. It says find the measure of angle ACO. Well, ACO is this angle here. Well, remember this is the angle. The vertex is what you measure, so I'll let you answer that one. Then they start talking about arcs. Remember, the arcs are the outsides of the circle. Remember, the arc of a circle is the same as the measure of the inside of the circle. So, just for instance, let me rephrase that, it's the same as the measure of the central angle that forms the arc. So what I mean is if I have an angle that stops at the center, if that angle is 40 degrees, then this arc that is created from the sides of that angle, this arc here, is the same measure. So if I have a circle and it's at the center, must be at the center, and notice that the sides of this angle intercept the arc from here to here. Oh, that looks like a Pokemon ball. Let's say that this was 120 degrees. Well, then that arc created would be 120 degrees. The green arc would be 120, right? And if this was 210, then this piece of the arc out here would be 210. And if this was 5 degrees, and it's not, but if this was 5 degrees from here to here, then this would be 5 degrees, okay? All right, so with that in mind, it says the measure of AC. Well, this is AC. That's arc AC. So you want to look to where's the angle. Well, here's the end, and it always goes to the center of the circle. So this is my angle. So what's the measure of this angle? It will be the arc would be the same thing. So I'll let you answer that. And then it says the measure of CB. Well, here's arc CB. So I look to the ends of the arc, which is here and here, to the center of the circle. I connect those three. So that means that this is my angle. Whatever this angle is, this arc's going to be. So I'll let you answer that. And then AB is from here to here. Now this is a trick. It connects here to here in the center. So that's a straight line. So what would this be? Got to think about the measure of straight angles. And then the measure of CBA. Well, C to B to A. Notice there's 3 letters there. And I know this isn't part of the question, but notice there's 3 letters. That means you go the long way round. If they would have just said CA, I would have went this way. But because I saw 3 letters, I knew I had to go through letter B like this before I got to letter A. Okay? So that means CBA is this arc. So I look to the ends, and I look to the center, and I form this angle. Now be careful, because instinct is to say, well, it's this measure. But that's not the side that my arc's on. My arc is on this side. So this measure. So you have to figure out what this measure is. And that'll be the same as your arc. Okay? All right, so try those and let me know what you get if you need to. And then 18, it says the measure of angle A, if the measure of A is 30 more than twice the measure of B, the sum of the measures of the two angles is 180 degrees. What's the measure of each? All right, so if the measure of A is 30 more than twice the measure of B. All right, so the measure of A is 30, more than means plus, twice means multiply the measure of B. So A, oh, I put an angle. So the measure of angle A is, measure of angle A is equals 30, 30, more than plus, twice to the measure of B. Okay, and this is A, by the way. Okay, all right, so then it says the sum of the measures of the two angles is 180. Well, that means angle A plus angle B equals 180. What's the measure of each angle? Well, I don't know over here because I have two variables. But over here, I know A equals 30 plus 2B. Well, that means everywhere I see an A, I can replace it with 30 plus 2B. So over here, instead of A, I can say 30 plus 2B, and then bring down this plus B equals 180. So notice, because A equals 30 plus 2B, in the place of A, I put 30 plus 2B, and then I just wrote down the rest of the equation. And then you solve. And that'll give you B. And then once you find B, you plug it in here. Right, so see what you get there. Looking at 19, what you need to remember is that you have intersection and you have union. Union is going to include all of both, whatever you're talking about. Intersection is going to include only the overlapped parts. You're only going to include the overlapped parts. So if I look at letter A, it says, what's the intersection of this plane and plane B? Well, where do those two planes intersect? Notice this intersection. I only want where they overlap. So they overlap here. So what are those set of points called? Well, those set of points are called YZ. All right. So then B says, angle ADF, D is the vertex, so I start at A, I go to D, stop at F, and line BE. Well, here's line BE. And I only want where they overlap. So where's the only place they overlap? Right there. What is that? Point B. Okay? All right, so now hopefully that you've got the hang of it. Line AF, which is here, and BE, which is there. We want the intersection. Intersection meant only where they overlap each other. So what would the intersection of that be? Let you try that one. All right, now D, angle CEF is this angle. Line CF is this. I want where they intersect, the points where they intersect, all points where they intersect. Okay, so I'm going to let you try that one. And then E says segment AE. So since it's segment AE, whoops, I didn't mean to do that. Since it's segment AE, that means it stops at A and E. It doesn't keep going. And line FE. Well, line FE keeps going, doesn't it? And notice we have the union. So I want all the points that are included. All of them. So technically, I want the whole line here. Because not only do I want this piece, I want all of it. So the union would actually be line AF, which could be called line FE still, or line AE for that matter. So I want all of those points. Okay. All right, looking at the next one, it says BD, but that little open dot means don't include D, so I'm not including that, but I am including B. And it says segment BA. So A is in, and we want the union, so I want all of the points that are included. Now, I'm going to let you answer it, but remember, D is open, so it's not included. So I want from A all the way to D, but I need to make sure whatever I put up top here tells me that A is included, but D is not. And the reason we're including this whole thing from here to here, except for that, is because it's the union. All right? So we're joining them together. So see what you get on that. And then G says A to E, neither included. And then A to F, which is from here included to here included. But no, I'm sorry, it's a line. It's just blurry up here what I'm looking at. A to F, the line. So it actually keeps going forever. And it's, again, we're on intersection now. So where do they intersect? What's the only points that there are? Well, hopefully you can look and physically see, well, they would intersect between those two pieces. So this part of the line wouldn't be included. This part of the line wouldn't be included. But everything between there would be included unless it's an open dot. So you have to be careful. Put your letter and letter, and then make sure you put the correct symbols up top. All right. And then last one, what's the intersection of AE and UF? AE is from here to here. Whoops. EF from there to there. I want the union. So I'm going to let you try that one on your own.